we're going to start talking about what forces do to materials. Things like a wire like this. When I pull on this, what kind of force am I exerting on it? The tension force. We've seen that before. And if this was a spring, the spring stretched. For something, a wire like this, you don't see it stretch much. If this is a rubber band, of course it's going to stretch more. If it's a wire, it's going to stretch less. Those properties of these materials here we have to account for. If you're building a bridge with these long cables, you have to account for those stretching a little bit when you put all that weight on there. You support it all with something. Okay? So we're going to talk about stress and strain now. The stress is really a measure of the stress, like the force that I'm exerting on something, and the strain is going to be a measure of what happens to it. Okay? I'm going to write down a definition in words for stress and strain, or just a couple of equations for them, but these aren't things that you're going to need to calculate problems. Okay, I'm just using it to kind of give us background on what they are. I'm going to give you one equation at the end of it all that puts stress and strain together. Okay? And so I'll tell you when I get there which one you're going to need and the one that you're going to use all the time. You won't have to define these words, but you might see them in problems so you should know what they are. Stress is just the measure of that force that's causing a deformation. It is the force per cross-sectional area. So it looks a lot like, or looks the same in the form of the equation here, as pressure. We don't call it a pressure. We just talk about it in terms of this stress here when we're relating to a stress and a strain. A force that's causing a deformation here. It has units of newtons per square meter, just like pressure units of pascals. We just don't ever call this a pressure because we're relating this to these materials that we might be either stretching or compressing. So, as I was saying, we don't have a special variable for stress, and you're not going to ever have to solve for what the stress is. What we're going to be looking for are things like the forces, or what actually happens when the force acts on something else. Strain is a measure of what happens because of this force. So the strain is equal to the change in length. And we're going to have an absolute value around this over the original length. And in terms of variables, we'll just write that as delta L over L naught. This is the strain. It's a measure of the deformation, right? The change in length that's happening because of this stress over here. We're dividing a length by a length here, so let's just make a note here that this is a positive unitless quantity, because we're doing meters by meters or length by length, whatever that may be. And stress is proportional to strain. Constant of proportionality is called the elastic modulus. for tension and compression forces. And tension doesn't have to be just something pulling like on a string, but things that are stretching or compressing by just a push or a pull or on a wire or something. These are the kind of forces that we know about now that we're going to deal with. The elastic modulus is called Young's modulus. And when I'm saying tension and compression here, we just mean things that are changing length, like this, just straight one way or the other, or like this. There's no twisting, there's nothing like that. We have a different modulus for those, what we call a bulk modulus for something else. We're only going to deal with these ones here where we have a changing length that's going to be linear here. No twisting or anything like that. And if the stress is proportional to strain, with this being the constant proportionality, that just means that the force per area, the stress is proportional to strain, which is delta L over L naught. The constant of proportionality just gets multiplied here by the strain, where this Y is equal to Young's modulus. Kind of a curly looking Y. I don't care how you write it, but that's what it is here for that constant. So that Young's modulus, or the elastic modulus, this is just a property of the material. So of course you'd have a different Young's modulus for something like the wire that I was pulling on over there, or a rubber band, or a string, or something different. Those would all have a different Young's modulus value. Okay. This is the equation that puts stress and strain together, that relates the stress to the strain. I'm not going to ask you to calculate stress or strain individually. You'll use this to solve for things like what happens when a stress is acting on some object. Okay. Young's modulus, those are constants. In your book, you will have a table on page 314. For a table of all those values there. And there's only 7 or 8 of those in there. If you have your books, open up to that table on page 314, just so you can see what it looks like. This is another one of the tables that I will give to you, that'll be just on this sheet with all your constants here for the exam. But you'll see all these numbers on here. Most of them are on the order of 10 to the 9 or 10 to the 10th. And they give you different materials, brass, copper, aluminum, whatever you have on here. Most of these work for either a tension or a compression, basically either a push or a pull kind of force, but you'll notice there for bone, you'll have a different Young's modulus for a tension or a compression force. All the other ones are going to be the same for either type of force. Okay. But that's where you'll find these values right here. So you just look that up in the table. I might ask you to solve for it, and if you solve for it, you might be able to tell me what the material is. But it's all right there in that equation. And you'll hear the word stress and strain maybe when you're reading problems or reading the book, but with what you're going to calculate, you're going to calculate something in this equation right here. I'm not going to ask you for the strain or the stress. Okay. Is that clear on the result there, the one that we're going to need? This is number 1 on your objectives, I think. Yeah, number 1 there.